Do you ever have arguments at home about leaving appliances on and wasting electricity? In this video, we are going to look at measuring energy use in electrical appliances. The unit of energy is the joule. However, when dealing with electricity, we actually use watts. A watt is a measure of power where 1 watt is equal to 1 joule per second. So a 100 watt light bulb uses 100 joules of energy every second. An electrical device will have a power rating. This is the amount of electrical energy the device needs to work. We can calculate how much electrical energy a device transfers by multiplying the power rating, watts, by the amount of the time the device is on for in hours. The unit of electrical energy transferred is the watt per hour, WH. This is likely to be a very large number, so we usually give the number as kilowatt hours, where 1 kilowatt hour is equal to 1000 watt hours. Let's look at an example. A computer has a power rating of 250 watt. If we use for 6 hours, how much energy is transferred to it? Can you substitute the values into our equation? So, how much would that cost to use? Did you get 1500 watts or 1.5 kilowatt? Either the case, you are correct. To work this out, we have to know how much a kilowatt costs. This differs between different countries, different companies within a country, and even different tariffs from the same company. A whole office of computers, the price starts to clock up quite quickly, and that's before we think about the lights and charging our phones. Think of a spanner loosening a fixed nut, or a child on a seesaw, or a door opening around a fixed hinge. All of these things are connected by something called moments. A moment is the turning force around a fixed pivot. The pivot, the nut, or the middle of the seesaw or the hinge. We can have one important acting which results in turning force. Or if something is balanced or in equilibrium, the moments are equal and opposite. To be balanced, this lighter child needs to sit further away from the pivot, and the heavier child needs to be closer. This is because the size of a moment is determined by the force and a distance. So the moment of lighter person is 500 Newton multiplied by 2 meters is 1000 Newton meters, and the heavier person is 1000 times 1 meter to gives 1000 Newton meters. Did you notice that moments are measured in Newton meters, Nm, because force is measured in newtons, N, and distance in meters? Note that the distance must be the perpendicular distance from the pivot to force. Here is another example. Can you work out what moments the woman is applying to tighten the wheel nut? Pause the video and work it out. Were you careful to change the 30 centimeters into meters? We can also place this formula into a formula triangle. Forces equals moments divided by distance. Distance equals moment divided by force. And moments, as we already know, is force times distance. Here is one more question for you to try. Pause the video and work it out. Did you get it right? For this seesaw, we do actually say clockwise moment and anti-clockwise moment must be equal. So there we have moments. Moments are measured in Newton meters and the force multiplied by perpendicular distance.